In this quick video, I'd like to look at a homework problem that unfortunately had a typographical error in it. Here's the problem. It's an interesting situation. Here we've got a medical facility that's going to look at 200 people and test them for a disease. Their strategy is to break the people up into 20 different groups of 10 people in each group, take the blood sample from each of the 10 people in the group, mix that blood sample together, and then just test that one large blood sample. If they're lucky, it's a little bit of a gamble here. If it turns out that no one in that group has the disease, then sure enough, there they are with only one test. On the other hand, if the test shows up positive, meaning that there's at least one person there, then they've already done that one test. They'll have to test each of those other people. That'll make a total of 11 tests, which isn't much of an increase over the 10 if they had just been testing everybody as they went along. The ending question is, and there's two different ways that this question could be phrased, and compute the expected number of tests for each group. The calculation that the webwork was using was not for each group. It was looking for the total number of tests. The total number of tests. Now, do you see what the difference is? The total number of tests will be 20 times the expected value for each group, because there are in fact 20 different groups. So there's two ways that this question could be asked: for each group, and the other one is for the total number of tests altogether. So we're going to look at both of those. I've put both of those problems down in that homework set so that you can work the same problem twice, one when you're looking for each group, and one when you're looking for the total number of tests altogether. To understand how to work this problem, there's a quick review of a frequency distribution. Notice that this frequency distribution, in a frequency distribution, the total of the frequency is always 1. So these are actually calculating probabilities. We can find the average of this population in the following way. You just have to take x times the frequency. So 2 happens about 20% of the time, so that's going to be about 0.4. This will be a 0.9, and this will be a 2.0. The sum of those is going to be the mean of the population. That'll be a 3.3 in this case. This ability to calculate the mean of a population from the frequency distribution becomes really kind of important. In this problem, let's think about the problem again for a few minutes, and look at it in the following way. Since the probability of an individual having the disease is 0.08, the probability that a person does not have the disease is 0.92, because they either have the disease or they don't. So the sum of those two has to be equal to 1, and the probability of not having the disease will be 0.92. This is the probability of not having disease. Okay. That means that if we had 10 people and looked at the probability of all 10 of them not having the disease, that would be 0.92 raised to the 10th power. Okay, now I've summarized some of this on this other page, so let me just go back to that. The probability of only doing one test, that means that none of the people have the disease, is going to be that amount. That's what you get when you put 0.92 raised to the 10th power into your calculator. You get that probability. Kind of a messy number for sure, but that's what you get. Now that means that the probability of someone having the disease in that group, or in other words having to do 11 tests, would be this amount. Notice the sum of those two adds up to 1. Therefore we could find the mean of the population by 1 timesing this, 11 timesing this, and adding those two up, the same way we were calculating the mean over here. So the mean is going to be that much for an individual group. So that would be the answer if the question is, what's the expected number of tests necessary for each individual group? If the question is, what's the expected number of tests, the expected total number of tests, then we'd need to take this number and multiply it by 20, because there were 200 people, remember, and we were dividing the people, those 200 people up into 20 groups of 10. So that number is the expected value for each group of 10, and if we wanted the total number, then it would be 20 times that particular amount. Okay, I hope that's helpful.